says 20, but it's actually supposed to be 21. Okay, and it's just a circuit. So a circuit, this is just over power rule. So you take the derivative of this using power rule, and then your answer tells you where question 2 is. So like if this is the answer to question 1, then this is question 2. And then the very last question should have loop back to the first one. So they did that. They turned it in. They turned in assignment 10. You can email those to me or give them to me now if you want. Well, you don't have that one done. I asked them to do 10 more questions from the book assignment in class and 5 more questions for homework. So you need to do 15 of the next book questions and do that. And you'll be caught up. Yep.
That's what it says on half.
Oh my god. Did you not? No, I didn't. No.
Dude, you're gonna get 7.5 out of 10.
I'm gonna be on top of my game right now.
Oilers.
I do not do
I love Euler's method. I think they talked about it in physics last period. I wasn't paying attention
Oh, of course.
Everett, did you understand that equation? What was the application?
It just didn't have time in it, so you don't really need to plug in time.
Was it just
Oh my gosh, you're right. Shoot. Okay. Now that makes sense. I wasn't paying attention at all.
Andrea, she'll be out.
first.
Olivia's not here today.
I didn't have a calculator.
Got a lot of people out. Or late, one to two.
We were just talking about this last period.
Talking about what? You're talking about what last period?
Euler's method. They're just like Euler's
Why were y'all talking about it
constant
last period?
physics.
You'll have to let me know how connected they are, because I don't know what y'all do with it in physics.
I mean,
Okay.
we were doing PVA.
I need your homework assignment 15.
I didn't have a calculator at home.
This is fun. This is a 9 and 10. We'll just put them inside too.
I was also busy. I was
Okay, if you just came in, there's an assignment I've taken up, so you got about 30 seconds to get it in to me. Okay, if you're over there not listening, you're going to end up getting late credit on the assignment because you don't know what you're supposed to be doing. Part of the reason why you need to be here on time.
Do you have a pencil? Oh, I'm so sorry. Do you have a pencil I can borrow? Thank you.
I feel like I have so much energy today, and I can't sit down.
Well, let's put all that energy into your math.
Okay. Or maybe we should go, like, outside, you know?
Well, yeah, when class is over, you can.
Okay.
All right. So again, if you're just getting in, I need assignment 15 from you before we get started here. So you need to do that here quickly. So we, first off, we're going to look at just about, I think it's like 4 questions on assignment 16. You may notice that the 4 handouts you picked up today, 2 of them make up 16, and then the other 2 make up 16. So that's the downside of me numbering them, is sometimes it's going to be a little bit off. So the one that says something about Euler's method actually needs to be number 17. So if you would please renumber those 2 from 16 to 17. And now's the time to do that. Meaning when I ask for assignment 17, next class, if you don't know what that is, then that's going to hurt your grade. So renumber it now, please. Okay, so what I'd like to do is near the back page of 16, we're just going to do a couple of these, and that's actually an A-B topic. But it's an A-B topic that a couple people in here last week said that they needed reviewed on, and somebody in my first period said they needed reviewed on. And you need it on a question or 2 for assignment 17. So we're going to talk about a couple questions that are review, and then we'll do the next BC topic, which is called Euler's method. And it's not a very difficult question type or anything like that, so pretty easy one to get checked off today. And then I put on the agenda there, all the first quizzes have been made up now, so I will pass those back to you, but you might need to remind me. Okay, so this assignment, the one that's the true number 16, is about the fundamental theorem of calculus. And I don't guess you have to know this, but just for your knowledge, there's 2 big fundamental theorems of calculus: the fundamental theorem of calculus and the second fundamental theorem of calculus. Just so you're aware, those 2 are pretty interchangeable. Depending on which calculus textbook you look at, they might consider this the fundamental theorem of calculus. After you do the antiderivative, how do you deal with these bounds, the limits of integration? Some people consider that the first fundamental theorem, and some mathematicians consider it the second fundamental theorem. That's not the one I want to talk about. The one I want to talk about is on the back page. I tend to call it the second fundamental theorem, but again, some textbooks actually call this the first fundamental theorem. Okay, so I'm going to go through question 21, and I'd like you to copy along with me. We're going to do this one the long way, and then the next three we'll look for and practice shortcuts. But again, this is something you need to remember from AB to apply it for even some of our new stuff for BC topics. Okay, so first off, if I need to do the antiderivative of this, just undo power rule a couple times. Okay, and then one time you need to plug in x everywhere you can. So everywhere there is a t needs to go in an x. Subtract, and then the next time everywhere there's a t, we're going to plug in a -3. So can't do too much with this. I've got a 1/3 x cubed minus 3/2 x squared. But all of this we can do, and just to simplify the process here, I'm going to throw it in the calculator real fast. Okay, well I said fast, but I don't know. Maybe not fast. Okay, I got 22.5, which is about, or is 45 halves. Now you could do that by hand, obviously. Just would take a little bit longer than throwing it in the calculator. But now we're going to turn around, and the question wasn't trying to get us to just do that. The question wants us to find the derivative of capital F. So all of this is still capital F. I did the antiderivative. Now when I turn around and take the derivative of this, so the answer to the question, I'll bring the power down, lower the power by 1, bring the power down, lower the power by 1, and the derivative of the constant would be what? 0. So this is the answer to the question. Now compare this to what we started with. Obviously, since this is referred to as either the first fundamental theorem of calculus or the second, either way is important enough that we need to recognize this pattern. So anytime you want to take the derivative of an integral, as long as the bottom limit is a constant, it doesn't matter what the constant was, because notice the constant made up a constant, made up a constant, but then when you turn around and take the derivative, it ends up going to 0 anyway. So it matters not what constant it is, but if the bottom's a constant, all we really did is end up plugging x everywhere we could. This became x squared minus 3x. You should recognize this pattern type and be able to say, I will go straight to that. Y'all remember talking about that last year? Okay, so if we did the same thing here, I know f, I want to know f prime. To take the derivative of an integral, those are inverse operations. As long as the bottom is a constant, this just gets plugged in everywhere you can. So the answer is almost cosine squared x over 1 minus cosine squared x. There's only one catch. Now, if you want to know why this works, or if you want to see how it works, you've got to do it the long way. You can do the antiderivative, plug in cosine everywhere, subtract, plug in 2 everywhere, and then turn around and take the derivative. But what's the other thing that we sometimes have to do with this?
Derivative of bounds.
Right, times, multiply it by the derivative of the upper bound. I believe that's just an application of chain rule, but obviously it's kind of hard to see. So you can do it the long way, like I did in question 21. You can do the antiderivative, you can evaluate it, and then turn around and do the derivative. But since the derivative is just undoing a lot of the antiderivative work you did, it's quicker to just know the pattern.
Wait, what would happen if you have two, like, variables? Like you have a cosine x and then an x for the two bounds.
Well, we'll talk about that on question 25. Okay, so 23, if I want to know the derivative of an integral, the bottom one's a constant, what's the first thing I should do to start my answer here? Okay, plug in x cubed where? All right, everywhere you can, everywhere there's a variable. And just remember, times the derivative of the upper limit. Why didn't I do that on question 21?
Would be 1.
Right, and multiplying by 1 doesn't do anything, so you don't have to think of it there. Okay, I want you to write down what you think the answer to 24 is before I write it on the board. That way, if it's not clicking, you at least know to ask me about it later. Okay, did you get e to the x cubed divided by e to the x squared plus 1?
Times e to the x.
Very good. Times the derivative of the upper bound times the e to the x. And of course, you could maybe simplify that some, but we don't need to for now. That's fine. So, a mathematical pattern that comes up often enough is considered fundamental theorem. Whether you want to call it fundamental theorem 1 or fundamental theorem 2, very easy, but again, I'm highlighting the part that students tend to forget. So, does that all seem okay? All right, so question 25, why can't I do the same thing on question 25?
The bottom sum.
Right, that only works when the lower limit is a constant. It doesn't matter what the constant is. Constant could be 0, 1, 2, or even -3. The reason it doesn't matter is, again, when you plug that constant in, you get some numerical value, but then when you take the derivative of a constant, it just goes to 0 anyway. So no matter what this is, no matter what this is, no matter what this is, that part just goes to 0. But back to your question, if the lower limit's not just a constant, you aren't using one of these fundamental theorems. You would have to do it the long way. You'd have to do the antiderivative of this, plug in cosine, subtract, plug in square root of x, and go that route. So no shortcut there. Okay, so of course I will ask you to practice more of this worksheet when time permits, but for now this is the topic I needed you to think about for a few minutes. So if you need to write yourself a note on how to approach that, then please do. And I will pause for just a second before I move on to assignment 17, sorry. Okay, so our next BC topic, so this is actually the 5th one of the year. This is actually supposed to be number 17. This is the one you need to renumber. It says 16 on there, but you need to change it to 17. This is called Euler's method, and honestly, there is a formula that you'll need to learn in this, but probably one of the more important parts of this is knowing what you're trying to do. So Euler's method is a way to approximate a solution to a differential equation. So we have some ways to actually solve differential equations that are not approximations. If you think about separation of variables, how we separated the x's and the y's on one side so we could integrate both sides, that is solving a differential equation. Some differential equations, though, are not solvable by hand, and so occasionally you just need a very good approximation. That's what this method is meant to do. So first off, we need to label this guy. This is called the step size. This is how far we're going to be moving from one step to the next. And you're going to see that a couple of these questions, I don't know, they get a little repetitive, which I guess is good, but there's very, very little calculus in this at all. So what we're going to start off with, this whole page is for this first question. The other pages have similar questions, but this one's really spaced out to try to emphasize what we're doing. So let's first write the equation of a tangent line at 0, 0. So remember, tangent lines are linear. Point slope is your friend. Plug in the point x1, y1. But typically, how do we go about finding the slope in calculus class? Slope is derivative. And honestly, this is the only real calculus part, is understanding that this is the derivative, this is calculating the slope for me. So at the point 0, 0, the slope is 1 plus 0, or 1. So at 0, 0, it needs to have this equation. It needs to have this slope and this equation. But we're only going to use this temporarily. We're only going to do this for 0.5. So from x equals 0 to x equals 0.5, we're going to have it have a slope of 1, or an equation of y equals x. Now, to make this more accurate, our new point now is at 0.5, 0.5. I'm looking right here. Now what we're going to do is we're going to make the next step. So I'm going to figure out what's it look like between x equals 0.5 to x equals 1. But I want it to be slightly more accurate. I don't want to keep using the slope of 1. The slope of 1 was what the slope was at the point 0, 0. Now I'm at the point 0.5, 0.5. So this is what the tangent line equation will look like. How do we find slope?
Plug it into the dydx.
Okay, plug it into the derivative. You get 3 over 2. So from 0.5 to 1, it has a slope of 3 over 2. So from 0.5, we're taking this point. Now we're going to do a slope of 3 over 2, but just for one step, just for a half of an x. So that would be like, this is really hard for me. Up 1, right 2, but that's too far. Oh, that's not right 2, that's right 1. Hello? I do. Sure. Yep. Yep. Patrick, you need to go see Mr. Kaminsky. Phase 2, first floor office. Okay, so we've got this slope at this time. So now this new point, I'm going to try to go up 3, right 2. Now again, I'm only going to right here. So 3 over 2 is the same thing if I only go over a half. It's like this is being divided by 4, so this is being divided by 4. So that would be at 1.25. So it doesn't look like there's much different here, and I'm trying to color coordinate them. But I took the slope at this point and used it for one step. Then I recalculated the new slope and used that new slope for the next step. And now I've got this new point at 1.25. So we were here, and now we are here. So for the next little piece, we are going to start our tangent line at 1.25. And we're going to use this for our next step. So again, you should be able to write the equation of the tangent line pretty quickly. Slope comes from derivative. Again, I'm using the new point. So when x is 1 and y is 1.25, If you plug that into the slope formula up there, you get that the slope is 5/2. And so if you go 5/2 from that point, that would put us at, so I'm doing one more step over, that would put us at 2.375. Now, again, it basically looks like I'm just kind of filling in like we did with slope fields. But again, with slope fields, you're just guesstimating based on the flow of these lines. Euler's method is saying, all right, if you know the slope during this time, use that slope for a moment. Recalculate the new slope and then use it for a moment. And then recalculate the new slope and use it for a moment. So it makes it a little bit more accurate. Now, what if I wanted it to be as accurate as possible? What would I need to change? Okay, and would you want the step size to be bigger or smaller? All right, so if you had like a computer, if you made the step size like 0.1 or something, every 1/10 of the x value, it updates the slope value, then it gets more and more accurate. So that's it. So again, I'm going to practice this again on the back with you in a table to kind of help you see and formulate a quicker way to get these answers. But this is ultimately all we're doing. We're taking a point, finding the slope, using that slope for a second. Get another point, find the new slope, use that slope for a second. Find the new point, find the slope at that point, and then using that slope for a second. And all of that creates better and better estimations. Okay, so on to the back page. One more example with you as a table, and then we can do the one after that together as a group. But first off, it wants us to calculate this, calculate the step size. Now, if you're not familiar with this symbol, this is the delta symbol. In mathematics, that just means change. Delta x means the change in x. So this is the step size. How much is x changing? So I know the point at 1. I want to know the point at 2. And they're wanting us to do this over 5 steps. So how big does that make each step? 0.2. Very good. So think about how much distance you're traveling. You're ending at 2, starting at 1, which means you're traveling a horizontal distance of 1. And if you divide that into 5 equal steps, then each step value is going to be 0.2. So down here in the table, we have a starting value. We know when x is 1, y is 3. We can use this derivative to figure out the slope when x equals 1. So the slope is 2 times x. When x is 1, that slope is 2. And so if I know at x equals 1 it's at 3, and I know what the slope is there, I can estimate where the next point is going to be, just like we did on the graph on the other page. Now, this is probably how you want to memorize this. I really think that anything else is kind of not very efficient. But the new y, and it's the same thing we did on the front side, I just didn't phrase it this way, is like the old y plus the rate that it's moving at times how much you're moving. So for example, this one is at 3 plus, and you need to write this in your table. I'm starting at 3 plus it's changing. It's changing at a rate of 2 for this long, for 0.2. Now, this will be a thing, an assignment you need a calculator for. If you don't have a calculator in front of you right now, just hold off. Did you already go down there?
Yeah.
Okay. How many days of OSS did you get?
It was like me.
Okay. And then there's your new point. So I went from x, I added a step, and here's where I think the next step is. that should kind of make sense. It's going up at a rate of 2 to 1, but only for a fifth of an x. So it's going up 2 divided by 5, which is really 0.4. So there's where the second point is. Okay, now we can think about, well, what's the slope at that time? So the slope is 2 times x, so 2 times 1.2, which is 2.4. And then this is where you're going to start to see the repetition, and this is where it's going to get a little bit easier. The next y value is going to be this guy's y value. We're starting at 3.14, plus it's moving at a rate of 2.4 for this long. That's how big the step is. So you could throw all that in your calculator and get 3.88. Except that's the y value, sorry. This is 3.88. What's the next x value? Okay, let's just go ahead and fill in all of these. If the step is 0.2, we're starting at 1 and ending at 2, that makes sense. Okay, so now I know it's at 3.88 when x is 1.4. Okay, plus how fast is it changing? So think about the slope. It's 2 times whatever x was, so that's 2.8. It's double x. Again, I'm getting this from up here, by the way. It's in the directions. It's given to you. In fact, it might be easier if we just put it here. Okay, so it's going up at this rate for this long, and that gives you the next y value, 4.44. The rate when x is 1.6 is going to be twice that, 3.2. So the next y value is going to come from the current y value plus the rate at this time for how long. Throw all that in your calculator, you're up to 5.08. Okay, now when x is 1.8, the slope is 2 times that, which would be 3.6. So what would I need to put in my calculator for this next part? Right. So we're taking where the y was at the last step plus the rate that is changing at that step for how long we're at that step. And that gets us to 5.8. Okay, what do you think should go in here? Okay, what do you think should go here? Okay, and then what does that give me? Okay, and what does that mean? What was that? What was the question? We got so wrapped up in the process. What were we trying to do? Okay, and what do we estimate f of 2 to be? Not 6.6. Right here. We were actually done right there. This part doesn't matter. This would be if you're wanting to take one more step to 2.2, which is past what we need. So don't get too wrapped up in that. So this formula, your next y value comes from the previous y value plus the rate at that time times how long it's going at that rate. That's all we did for those. So now let's do this one more together, and then I will let you practice from there on out. So we've got a point 1, 2. Now you don't have to do the table. I just think that that's a good way to organize it. When x is 1, y is 2. What else do we need to think about? Okay, so the slope or the derivative, same thing. and then that will help us formulate the new y. Okay, what is the slope at the point 1, 2? And how do you know? Okay, and how did you know? Right, the table is giving you the derivative values in this question. So if we're at 1.2 and we know at that instant it has a slope of 0.3, we can estimate, we can assume it's going to stay that same value for a while. Now we want to do this for 3 equal steps, and we want to estimate 2.5. So 1, 2, 3 steps. So how big does each step have to be? 0.5, 0.5, 0.5. That works out. Again, you can also just calculate it. Think about where you want to end. Subtract where you started to think about how much horizontal distance has changed. Divide that into 3 parts, and that tells you that you get 1/2. That tells you the step is 1/2. Add a half, add a half, add a half. 1, 2, 3 steps. Start at 1, end at 2.5. Okay, for the new y, what of these numbers do we need to use? How are we going to figure out what we're estimating this y value to be?
It's gonna be 2.
Okay, so we're going to figure out that it's probably close to this one, plus how are we going to guess that it's going to change?
The slope times changing it.
Okay, so the rate, how fast it's going up, times how long it's going up. And this should be the step, so this should be 0.5 again. Okay, this gives us our next y value. So if you threw all that in the calculator, you get 2.15. And now we just do the same thing. Now the slope during this time is 0.7. And now if we know how fast it's growing at that time, we can estimate where it's going to land at x equals 2. It's probably going to be near this y value, 2.15, plus Newton's method tells us assume it's staying at this rate for this long. You throw all that in your calculator, you get 2.5, so that's the next y value. Then once you're at this y value, the slope is 1.2. They're telling me that in the graph. So I'm going to take the old y value plus the rate for how long. All of that gives me the next y value, which is 5.8. And then I give Addison a hard time, except she's not in here. This is what we wanted. We wanted to approximate f of 2.5 is about 5.8. It's not exactly at 5.8, but using Newton's method, that is where it would end up being. Okay, so in all of this question, what calculus do you really have to know for this? Or what calculus are we using? Yeah, knowing that derivative is slope. Sometimes it might be in a table. Sometimes it might be in an equation. But really, if you know derivative means slope, the rest of this, again, can be kind of tedious. Very, 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 very rarely will you have to do a 5-step like this. It's not harder, of course, it's just more tedious. But you do need to know this formula. Make sure you have that copied down well. You might want to write it on the top of each page. But next page, it looks like each question is only 2 steps. So obviously you understand how we're computing through 5 steps. 2 steps is just less work. And then the last page has some 3 steps and a couple 2 steps, I think. So anyway. So any question, again, all of this is arithmetic, and you can use a calculator. You need a calculator. I don't expect you to keep up with all these decimals without one. But formula to memorize, almost no calculus you have to know to do these questions. You got to practice them enough to make sure that you can follow the process. But I'd say just as important as any of that is make sure you understand what you're doing. Being able to just follow the steps and get the answer is going to be great sometimes and not good other times. All of this is a way to approximate a solution to a differential equation. If you know this is a point, and you know the slope here, and you know the slope there, and you know the slope there, this is a pretty good approximation to what the real solution to that would be. And of course, that doesn't take a ton of work. Now, you're also welcome to just solve this. If you want to separate the variables, integrate both sides, plug in 0, 0, solve for C, you can do that. And I guess you might get an equation that's like a little tiny bit more accurate, but all things considered, that's pretty accurate for the work that we did. So, okay, is there anything that jumps out at you about Euler's method? You know his name is not Euler's, right? You've heard his name before, Euler? Okay, that was the mean part today. Okay, go ahead and try those, please. Again, make sure you number this as 17. And I've got my work up here if you'd like to check with mine as you work. I also have the answers on the class website, so make sure you check them before you turn them in. But that is the plan for today. And yeah, if you need to borrow a calculator, come grab one, please. You just bring it back at the end of class. Also, make sure that you keep your quizzes that I'm passing back to you. It won't be the last time you see some of these topics, so. So is this even close to what y'all did with it in physics?
It was some wacky thing. I don't remember.
That was not similar?
No, it was a constant, I believe.
I'll have to ask Mr. Root sometime.
I don't know. It had some weird symbol to it. I just remember hearing the name.
Oh, okay. Maybe you did Newton's law of cooling. Might have been that.
It had something to do with like velocity with respect to position and stuff.
Yeah, I have no idea what it was. One other thing to keep in mind is that since this first quiz, since the second BC topic we talked about, we did arc length after your first quiz, and now we've done Newton's Euler's method. So we'll do about one more new BC topic on Wednesday, review, and then we can have a second quiz.
Did you take off points for that? I guess I just wasn't very good at showing it.
Yeah, these are all.
I guess I just wasn't good at showing it.
Well, no, but look, that looks like -1. That looks like -1. They gotta look. They gotta be. Look,
Sorry, I was sloppy.
Look, you can also turn. If you can do it this way, you can turn the paper around with it.
Yeah. I did pretty good on this. I thought I would do pretty bad. Not bad for a first quiz.
Yeah, I got no problems with that.
Do you have a hole puncher?
Did you? There's about 12 of them around here.
Are you serious right now?
I don't know what I did.
I forgot to put plus C on all of them.
I forget.
Are you serious?
At least you didn't do it on a derivative. Did you?
I did. I put plus C on a derivative, and I didn't put plus C on the integrals. Oh my god.
If I remember
Generational
right, you're
fumble.
the first person to turn it in. Maybe you should slow down a little bit.
Maybe. Since I already checked my working.
Well, to be fair, I think I only took off one.
Yeah. No, you took it off twice.
Crazy fumble.
Oh.
Part two. Okay, so I will be taking this assignment up at the start of the next class. You guys have plenty of time to finish up the rest of these questions.
Oh, which number is this? Does it have a number?
It does, but I don't remember. That's why I asked you to number it when it's on the board. Wherever you've got a gap in your binder, I guess.
It must be like 14.
Okay, I'm going to grade these homework so I can get these back to you.
Yeah, it's 14.
But other than a couple A-B topics, remember this should be about 2/3 of your next quiz. ArcLink should be about 1/3 of the new stuff. Euler's method should be another third. And then on Wednesday, we'll look at one more new VC topic before we review the quiz.
Oh, this shouldn't be a bad quiz.
Yeah, to me, this is much easier. As long as you memorize the formula for ArcLink and you memorize this formula.
I already have. Mr. Townsend, did you ever play Dark Souls?
I've tried it a few times, but I never stuck with it very
I
long.
sketched the DLC box today in the library. Dark Souls 3.
That's what it looks like.
Yeah.
Is this with pink?
No, that's like a road.
Oh, it's a rope.
Something like that. I don't know.
Dark
Like a
Souls
cave.
1?
Huh?
Dark Souls 1?
3.
Oh,
This is the Ring City DLC.
I never played 3.
Dang it. Shoot. Ben, what'd you get on the quiz?
4. 3. I did 3.
Pretty good. I just did some goofy thing, pretty sure. And I was sloppy on the...
Obviously, I don't mind if y'all look through your quiz. You should learn from your mistakes. But again, make sure you finish up this Euler's method. I'm not going to give you more class time after today.
Wait, is it possible? Did you get this as my answer or this one?
I've got to answer the phone. Oh. I did not.
You counted this as my answer. This would just be checking to see if it was right or not.
Okay, where's your answer?
It's here. But I still didn't put plus C.
Jeez.
Okay, I can give you one more point.
You really had me. You great.
I'm actually so stupid. I put this it's actually so dry.
I somehow got a decent grade. I thought it was going to be
I'm so mad I put plus C's where I wasn't supposed to and I didn't put them where I was.
That's something I probably did on the AP exam. I'm going to be honest.
But then multiple choice was, I don't know.
Somewhere on the FRQ, I guarantee you I messed it up.
What's just a 13 out of 16? Is that a B?
I don't know, but that's what I
Put it in the
got.
calculator.
Yeah,
Because this one was a 75.
yeah, it's a B.
Okay, so I didn't get a C on the test.
I got a B. I'm happy about that. Calculus is like my worst thing.
Oh. Can I see your notes for this one? For this one?
Oh yeah, totally.
Thanks, gang.
My
Are you
pleasure.
excited for Friday?
Yeah.
Hey, it's better than a rehearsal. And yet
Football game.
they're still giving us an advisory rehearsal, just out of nowhere.
Sometimes you don't know like it's used to do something.
I already have an extended rehearsal on Thursday because of battery section beforehand. So it's just like, I don't want just another extra long rehearsal. I'd rather have it split up with everything.
Yeah. So like, I don't want to stay until the football field until like 10, because that's when I have sleep. I've been sleeping at 10 p.m.
I have insomnia, so I love pretty bad.
I forget to sleep.
You forget to sleep? How does that work?
I like to do things and I forget.
Isn't that just procrastination?
No,
Procrastinate.
like I do personal projects instead of sleeping, and I play on my phone.
That's
or I
fair.
doom scroll, and I forget to go to sleep.
I sometimes forget to eat.
I do that too.
You guys will get hungry?
Yeah, I forget I'm hungry.
It really if I just stop thinking about something I'm on, then I get hungry.
Interesting.
Yeah.
If I'm not paying, if I don't pay very close attention to it, I forget I'm hungry, and sometimes I just like my body isn't sure if it's hungry or if it doesn't want to eat. Both of those feel the same.
I can't really sleep very good. That's been a problem for a long time. So like on average, I get about like 4 hours of sleep every 8 days, I think.
That's crazy. I can't live with less than 7 hours.
I was a very big slacker sophomore year when I did A-Push.
Oh.
So I legit, sometimes I had nights where I went to bed at like 5:20 and got up at like 5:45.
Are you serious?
Yeah,
How did you survive?
I barely did. That was when I was falling asleep in county pre-cal class. Maybe. I know, like legit, like I got like a C second semester.
Did you
No,
0.2?
because I was actually asleep like every period.
Did he not wake you up?
Yeah, but
He did not.
change in X isn't.
It was bad.
Yeah, I used to not in calculus too.
At least it was pre-cal, not AB.
I nodded off an AB.
It would be bad if it was an AB for me.
It was fine for me. I just looked at it so I would figure out how to do the math based on the C.
I actually can't believe myself. 2 points.
That's kind of funny.
2 points.
You gotta admit that's kind of funny.
2 points. I'm never making this mistake ever again. Watch me do it next quiz.
I'm scared I will, but I think it's just integration. And since it's probably just set up.
Yeah.
Unless he does a calculator one. And then even then you just plug it in.
I need to get my grade up. I have a B right now.
I think I have a B. I may have an A, I don't know. I have like 3 half credit things. Like I just turned in like 15 I think first. Because I didn't have a calculator at home, I was too lazy to look it up.
You could download the calculator app though.
Yeah, I was also just doing like CPACs and stuff, so I just kind of forgot.
So fun.
Yeah, and then I didn't finish like 2 others. So I might have like a low A or a high B. I don't know.
You think we'll make finals at BOA?
Yeah.
Yeah, you think so?
It's Des Moines.
That's true.
We're further from the East Coast. We're gonna have a better time.
That's true. That's true.
There's like one really good school going. And
Did you
it's
figure out
like,
who it was?
So you integrated it and then you just do the balance from 1 to 1.
I'm probably gonna get like,
4th?
that's what I'm expecting.
What did we get? We got 6 at BOA last year.
And then do I just plug in
Record
the
smashing. Where we go
So
like
at all of the categories where we're the only 4A band.
middle of nowhere, Tennessee, 30 minutes from North Carolina,
Yeah.
and
2/3 plus T.
the competition was way easier.
No Benville. No Benville.
Benville was in like Orlando
Yeah.
with Broken Arrow because Broken Arrow got freaking exiled from St. Louis.
What happened? Wait, what happened?
You remember their show a couple of years ago? It had those like weird tendril looking things.
Tendril?
Yeah, it was like Over the Edge or whatever. and like the freaking the guard was like really raunchy looking, so they got banned because of the guard. Yeah.
It's like raunchy as a like.
But there's no negative in changing that.
And I had like leather straps and stuff on the legs and stuff. Like they were like crawling.
You
to
can't
the
like
front and stuff. It was like it was weird. It was really weird.
Change it up.
Is that legal?
Like they have a beauty standard also.
Are you serious?
Yeah.
It's just like how far you change.
What do they put in their water?
So if you go from like 1 to 0.5,
like for like
change
the
it.
garden stuff, they look like so it's just like
Wait, what was the show called again?
I don't remember. It was like 2022, I think. I believe. Like the guard uniforms, like compared to like think of it in a situation where it's high schoolers. In high school guard, you know? Like it's not like fully guarded, but like when it comes to like high school marching and like color guard, it's like
Oh my, it's not like too bad.
yeah, but when it comes to like
It's not too bad.
when it comes to like guard members,
It's not too bad.
but just like think of it like compared to like
This is some crazy beauty standards.
yeah.
It's not that bad.
It's not bad, but it's bad for
I didn't watch the
Yeah, it's pretty bad.
yeah. So it's like they got banned, I'm pretty sure, from cigarettes.
That is crazy.
Which is kind of funny, I think.
Do you know that Cadence first broken down? One of the texts of the marching text? Oh, that's like the little girl who's like always Abby.
That's a big.
Abby Lawson. She went to Broken Arrow. That's why like I don't know how to describe it. She's just really strict, I guess. I don't want to.
I don't either. I just don't want to write all this stuff down.
Yeah, like it's not.
I'm already
hard.
almost
It's
through
just
the-
tedious. I'm on the last page right now,
The last page is.
but it's just so tedious.
I don't want to. I don't want to.
Alright, guys.
I guess I'll do it, but like, I kind of don't want to do the last page because it's just like. I don't want to do pages that look like this.
Yeah.
It's just really bad.
It's like one of the pages, like remember the radioactive decay sheet?
Oh yeah.
That reminds me of that.
Yeah. Oh my gosh, I really hated related rates.
What?
Was that related rates? That was in the same unit.
That wasn't related right? Oh, that was
I think it was in the same unit. but
that was the
like,
freaking the E stuff. You know what I mean?
Yeah, you're right. You're right.
Like the I forgot what it's called.
What, when you separating variables?
Yeah, that
Yeah.
that
Okay,
unit.
yeah, shit, I got mixed up with something else.
That unit's my downfall.
No, I was really bad at related rates. I didn't understand it. Olivia had to like drill it into my head when I was doing like, I literally crammed like 2 or 3 days to the AP exam, and like somehow I went up from barely a 2 to a 4. Somehow. I don't know. I'm really bad at
Okay, so you're going from 1.5.
I just can't remember it all.
But your calculus is really good stuff.
Well, but it's changing.
Maybe it was just because it was taking fun as well. That might have
Changing
been
it.
it.
Taking
Changing
next year.
X is like absolute value, right?
Hey, do it. Do it. It's great. It's great.
I don't take honors chem minus, so I don't really know how that's gonna
If
go.
you're going
I'm better.
left,
I'm better at counting.
you know the
so
value here, and you're trying to go left, so it needs to be negative.
it was good.
Like, if
Please
you,
study.
you know, when we say count right,
Study.
so run for
Study your assets and
When you
bases.
say run,
Or else you will not
you always
comprehend.
count left or right.
Yeah.
For
Because
some
it's
reason,
like,
you wanna count
there's a
right
lot
or
of
left,
graphing
you
stuff
need
with
to make
assets and
negative
bases,
one.
and it's just
That's
like,
the same thing. So make your set negative.
there's an equivalence point where it's like,
Again, you
equal
can also
You already
take
lost
you
me.
out of it.
Alright.
If you're
Like-
starting
Yeah,
here, going there, 1 minus this would be
it's-
negative 0.5.
that's like late.
I already forgot what to do for the first step.
You get there's an X, and then there's a,
Oh, yeah. X,
and then there's a slope, and then new Y, and then just like, you can put in the Y prime, put in the X, and then like, put it into the formula, and then just like,
Are you gonna update my grade?
I thought I did.
You did?
Thought I did. You want me to
then you
take
should
a
already
look?
have like a Y, it should give you
11?
an initial Y.
No, I got a 12, so it's 13 now.
A 10?
Oh,
It should give you an initial Y as well. So yeah, just plug in the initial Y.
We should get extra points for telling you that you're my favorite teacher.
You lose points if I'm not your favorite teacher. You don't
Is that
get
how it works?
points.
Is that how it works?
Okay, it's been a long time, but the calculus teacher that used to be here like 20 years ago,
20 years ago. You're that old?
am I that old? Yes, I'm at least 20 years old.
No, I mean, like, you've been teaching calculus for 20 Wait, you weren't. So the last calculus teacher was here 20 years ago. So
Remember
that
how
means
you,
you've been here for 20 years.
you remember how you rushed your quiz? You're doing the same thing now with our conversation. Nothing I said had anything to do with that.
You said the last calculus teacher 20
Yes.
years ago. So that means
Yes.
you're the calculus teacher right now. So that means you've been here
Those
for
are
20 years now.
two completely separate things. There was calculus students 20 years ago. You're a calculus student now. That doesn't mean you've been a
Oh, I
calculus
thought you
student
meant
for 20.
calculus teacher 20 years ago.
There was a calculus teacher here
Not
20 years ago. She had a list of things that if you made these mistakes, you would lose points for. So you could get negative points.
You could
really?
get negative.
What? That's crazy.
Certain mistakes, things, important things like chain rule and stuff, that if you missed them, she would take away negative points. So
Wait, if she takes away negative points,
That's
that
not
means she
what-
gives it positive points.
that's not what I mean. I'm saying you get the answer wrong, you forgot chain rule, then you just earn negative point on that question. It's taking away from credit on another.
Oh, wait.
So
Yeah, that's a little.
I mean, technically, the grades you don't lose points, you just don't get points.
no, it's taking away points from another question. What it means.
That's
So-
kind of cruel.
So it's extra points taken away?
Extra points taken away, yeah.
Is that right?
So just some perspective on what I'm capable of.
Oh. Is that legal?
Is it legal?
School legal.
I mean, you can't give extra credit, so can you give negative credit? Extra uncredit?
I don't know. I can try to put in a negative grade in gradebook.
Don't.
Anybody brave enough to take the negative grade and see if it works? Okay. Negative what? 100?
500.
Does it work?
No.
Oh.
So it is.
Invalid data was found. Please correct values in the entry field indicated in red.
Wait, wouldn't you just like do something similar, like 0 out of 100 or something? Like put a different assignment that's out of 100 and then put 0? No?
I could subtract 30 points, I guess, from another assignment.
Huh.
If anybody needs the pass in a few minutes, remember Diego's got the pass and he's just sitting there not using it, so.
Oh, it's the X, shoot.
Have you got the SpongeBob scheme yet?
Diego, use the pass or bring it back.
Oh, yeah.
Why scrub? This is not hard. You seem to big
Anybody take the ACT last weekend?
Yeah.
Yeah.
How'd it go?
It's gonna be me in December.
My coach? I don't really get much stuff.
And did you get 18?
I haven't found that yet. Why? Each one. Why? There's either plug one in.
That's not what but you're plugging in.
Okay, I'm almost done grading the homework, so I'll be coming around. You can ask questions if you need to.
One X is one.
What is X?
Three steps.
Hey, is this you wingding over here? Is this your wingdings? This has no name on it.
Oh, that's probably Diego's.
Yeah, but it doesn't look like Diego's. It doesn't look.
Oh, that is not me.
No, he wrote Wingdings on the top of his.
Yeah.
Yeah,
That's
no.
his name though?
Yeah, that's his name in Wingdings.
Wait,
No.
what are wingdings?
Yeah, that's
It's a font.
Oh, that's like an actual
it's
thing.
Yeah,
Diego
just a bunch of
and then
stuff.
I
Pardue.
didn't know that.
He wrote his last name too.
Okay.
I watched him.
Well, honestly, I thought it was him. But that does not look like Diego. It's got something HMN box. Thumbs down, HMN box is supposed to be Diego.
Yes, in Wingdings.
And then
We
P
looked at
banana.
Someone wrote that on their paper.
Yeah, we looked at Wingdings.
He's so busy doing that, he didn't finish his work.
Mr. Thompson. Here you go.
There's also this on the math portion of the ACT.
Are you serious?
But you could have solved it without calculus, but it was like the derivative of something of like the volume when like filling up.
Okay.
I think I got it wrong, but I didn't know how to work it.
I have no idea what that could possibly be.
You what?
I have no idea what that could possibly be based on that description. You shouldn't need calculus for any ACT questions.
Well, I used it for one, so that's not good.
Well, I'm not saying that it won't work on some. I'm saying you shouldn't need to use calculus. There is probably something else you could have done. How was the rest of the math?
Honestly, well, it was the first time I ever finished math with time left over, like ever. So the math felt good, and the science felt good, and then I was reading slow, so by reading I was rushed. But then English just felt normal,
Science tends to be pretty easy on the ACT because it's really kind of just read these graphs and then know one fact
Science is
per
my worst
section.
subject.
Davey Crockett, take a seat.
Science is my worst subject.
Sit down.
Are you senior?
Do you know Anthony Kong?
Yeah, science is off next year.
Anthony Kong, you know him?
Yes.
He said he took the ACT for the first time this weekend. And I asked him how the math went. He said he guessed on 3. And he looked them up, and 2 of them were right, so.
Okay.
I don't know how you remember questions after doing full science.
That's the impressive part about that. So he got all but one.
That doesn't mean he got the rest of them right. He just. He probably got most of them right.
Wait, and the same.
Are you done already?
It's not hard, it's just tedious.
How'd you look that?
Mr. Thompson, when's the next seating chart coming?
One more class longer than it was gonna be since you asked.
Okay, Mr. Townsend.
We do rates of change in here.
The rate of change of seating charts is changing because of what I said.
Does that look like Diego to you?
I don't know what that is. I wouldn't even want to know where to start.
We looked up wingdings. I finished the work and then I looked up wingdings.
Looked up. I think I did not.
So he just has the one.
He's never calling on Olivia ever.
Is he scared of his
Oh, he never called on me. Well, that's not entirely true. Mr. Ballinger tried to call on me to try to catch me because I didn't seem like I was paying attention, but I knew the material better than he did, so. Has he asked your guys' class, whenever you come across like a big word, has he ever asked who uses that word? Because he did that all the time for my class, and he didn't believe me that I used most of the big words.
Well, I'm sure I've said this before, but the problem with math for you guys is
Oh, yeah, I was like, I don't.
this doesn't really help you with.
Times 6.
He doesn't help you with anything. Pre-calculus helps you with like 2 or 3 questions. So it's really so far removed from geometry that you don't remember that part.
No, but like give me 6, actually just don't know.
It wouldn't make sense for it to be 8.
So, I mean, I'm gonna go for it now because
Yeah.
I changed on my because it's like, okay. Because like it's harder. No, it's just not really. It's not
Well, I'm gonna ask you to do it eventually, so. Okay, you can have that finished.
Were you there, Cam? Yeah.
you know, so like.
Yeah.
I thought you were on that day.
The end was good.
You didn't come drop your stuff off.
Nothing wrong.
Probably. Oh, I did put a new hint thing on your desk while your street number. It doesn't tell you what it is though. What is that?
Even circle.
Okay. Not exactly.
Wait.
It's not the unit circle, it's the unit circle tangent values. That's the values of, like, tangent of pi over 6 is square root 3 over 3. Tangent of pi over 4 is 1.
Is that for us or for a different?
I think you glance at it sometimes.
Helpful to everyone.
You can remember tangent values are the same across the unit circle, stuff like that. You haven't thought about in a while.
Can you not count? That is 39.
Look.
4.
See how that one flows? That was so good.
This is
Yeah.
that's not.
That's a 4.
That's either
Tell me what those 3.
25.494.
That's right.
Mr. Townsend, do you want us to finish 16 as well?
You do not have to work more on 16.
Okay.
I will ask you to do more of it later, so obviously the more you do today, the less you'd have to do later. But I'm more interested with y'all just doing a really good effort on 17.
Okay.
Can we just be like, realize you have so much work to do that you don't want to do it.
I'm working on it.
Is that a fly button?
Yeah.
That's
better.
This is the one I didn't have a calculator.
You wouldn't need a calculator if. Where's your calculator at home?
I was trying to find it.
Well, you can check out one for me for the whole year. But if you lose it, you got to pay for it.
That's the thing.
2, you could sign up for advisory to come in here. And 3, you had enough class time to get it done if you weren't wing-dinging around.
Me personally, do you?
Those are nice.
You let that slide? I mean, I don't really care. It's fun. I work hard on everything else, though. I just also didn't have time because I was doing like stuff outside. I was doing labor.
Okay, we did that on Wednesday. So that was a Wednesday night homework. Okay, maybe you were busy. Thursday night homework. Okay, Friday wasn't a day, so maybe do it Friday night homework.
Friday night I also was.
Okay, there's one time so far. Saturday. Saturday night. Sunday. Sunday night. You have 5 days. You're not gonna get.
I was busy every day last week specifically. It is like I'm not gonna make it a habit to not finish.
I'm not worried about you doing that.
Huh?
I said I'm not worried about you making it a habit.
I really I'm working on this right now.
And you can still finish it and get half your points back.
Oh yeah, you're right.
Yeah.
I forgot about that.
So you only end up losing a couple points. Not a big deal, unless you do it all the time.
That's on me. I'll like I forgot about finishing it and turning it back in. Sorry. Shoot.
Just a quick reminder: if you guys did forget to do your homework and you got half credit on it, you can still get half the points back as long as you finish it completely and get it to me before our next big quiz, which is about 3 classes from now.
So you get like a 75.
But the more important thing is that you practice the rest of those questions.
They were just the calculator ones. I just forgot to plug them.
Okay, but you need to find your calculator or check one out from me.
I think I may have an idea of where it is. It's just I put it in a. It was. I forgot to put it up after the exam, so it was still in like a Ziploc bag somewhere.
Okay.
I'll try to find it. That was wondering what it was.
And also, you've got enough class. Look, Ben's done.
Yeah.
I'm done. Are you done?
I was in the restroom.
I'm done. I started looking at the campaign I'm going to run for DP.
You're gonna run for president?
Is that a
I am the president for. No, it's a licorice pipe.
licorice pipe?
Yeah. I'm the president of the
I've never
D&D
had
club.
traditional licorice.
Video game club, okay.
And I'm running a campaign because I'm the D&D club president, so I have to run a beginner campain for
I bought
new
some
players.
new video game stuff. I bought a Asus Ally, like the handheld game thing. I was trying to wait because I didn't need it, but somebody had a really good deal on one used, so.
I mean, if you see a good deal.
Huh?
If you see a good deal, sometimes you just gotta take it.
Well, I mean, it was $450, which is a lot of money.
Yeah.
But that's about what they go for, except his came with a case, screen protector, a dock, a grip on it, and it had a 4 terabyte hard drive. And the 4 terabyte hard drive is worth practically $200 on its own.
Yeah.
So that's why I was like, you know what? I could probably just take out the hard drive, sell it individually, and make money. So I think I'm gonna do that.
Yeah. 4 terabyte hard drive's a lot.
Yeah. I was surprised he was selling it at that price, but
My computer I use for everything only has 2 terabytes.
I don't have a computer yet. That's what I'm saving for.
well, I used to do a lot of PC gaming, but graphics cards are just too expensive, so I'm trying to stay away from that now.
Yeah, I play.
It's too hard to keep up.
I got like a mid-range, a high mid-range graphics card about 4 years ago, and it still works for most games. I just have to run some of the newer stuff on lower graphics settings.
My graphics card is a 1070. It actually does decent, but it's so old at this point that it just can't. I mean,
Is that the same thing?
Depending on the game, it's fine.
Yeah. If you want to play some of the new, like
Dang it!
like Starfield.
Oh my gosh, I'm so stupid.
Well, see, I'm not that big on performance, but I really, really, really like 4K because I just got a 4K TV a couple years ago. So I really want stuff to run at 4K.
Yeah, I don't really have to worry about that because I just have a little monitor.
Yeah.
But eventually I'll have to replace things, but that's why I built it instead of buying it pre-built, because it makes it easier for me to know how to plug and play it.
Yeah, if you buy pre-built, they usually like give you a pretty cheap motherboard that's hard to upgrade.
Yeah, that's why I built it myself, because it was going to be a better quality for a better price point. It just would take me more time, but at that point I was like 12,
Yeah.
so that was fine.
My first PC I built, I put a motherboard in,
Yeah.
and I screwed it to the case,
Yeah.
but I didn't put the little spacer things in there, so I pinned the metal to the metal,
Ooh.
sparked when I turned it on. Took it to a computer shop thinking I just didn't know what I was doing, because it was the first time I did it.
Yep.
And I need a new motherboard, which then I need a new RAM. Never make that mistake again.
Never. I was very careful the first time I made it because it was expensive still. And I wasn't about to spend 2 more years waiting for parts.
Oh, also, the first time I bought a graphics card, I had to unplug some stuff, plugged in the graphics card, wasn't sure about where a wire was, made my best guess.
Yeah.
Turned on the computer, started smoking. The whole wire just got crisp. It was a wire to the hard drive.
Oh.
But I don't know, it still ran. It must have been like an alternative power line or something, I don't know. That was my dad's computer and I never told him. Because he would not have liked me messing with it like that.
Yeah.
It was like a GeForce. I don't even know. It was so like long before their current name.
Yeah. I don't remember what my graphics card is right now.
My dad.
It's functional, and that's as much as I need.
Honestly, if I built a new computer today, I'd probably just use integrated graphics and just call it a day.
Integrated graphics, I guess.
Maybe buy a cheap graphic card like when I found one used.
Yeah.
And that's a couple years old, so it's cheap.
What I did when I was building was I bought almost all of my parts on sale or used.
Yeah.
That's what Patrick does. Patrick bought all his PC parts from Temu.
I bought them from New
Buying
Way.
counterfeit PC parts? That's why Mr. Kaminsky needs to talk to you.
Like a secondhand thing or whatever.
I bought most of my parts from off Newegg because it's easy to watch.
Did you use a PC part picker?
No, I just researched everything and wrote it down.
It's a good website to like plan your build out, and like it'll let you know if stuff's not compatible or not, so you don't accidentally buy the wrong RAM or something.
I'll tell my younger brother that he's starting to work on building his computer.
That's the first step.
What?
I just gotta get a PC.
I right now.
Got one right there.
I want to.
That's a
I want to
PC?
build a.
Technically,
That's stronger than probably my first 4 PCs I ever owned.
he's got like
I want to build a.
64.
More than it took to go to the moon.
Yeah.
That's true.
My first computer probably had like 1K of RAM.
My dad used a
Like
Commodore
1 kilobyte.
64 when he was young,
Or
when he was in
Or
college.
2 kilobytes.
At this
maybe.
point, I want to build a laptop so that I can have a laptop.
Have you seen that video?
You don't want to do that.
I do.
No, you won't. Other than portability, it's not worth it.
Yeah, but like when I'm I mean, yeah, I'm probably just gonna take this with me to college and have my desktop. Yeah, I mean, I have a desktop computer, so I'm just. I will. I probably will, because it's
Why
just
not?
nice to have a little laptop to look
You get
stuff
a little
up.
laptop that's actually functional.
This is functional. It's just not very good.
Have you seen?
But I don't have to pay any more money for this. So.
Have you seen that guy who like installed Steam on like that little Google Meets PC thing?
Are you serious?
Yeah. It was so.
I mean,
it's such a
once
funny
once
video.
all of the school-based restrictions are off of this will be fine.
You can jailbreak those really easily.
I know, but I'm not going.
Definitely something you should say.
It's a little harder
I'm not
now.
on the tech. I don't care.
It's not like I did it. It's just.
It's
I
a
know
little
some
harder
people-
now because they've updated the software a little bit, so it's a little more tedious to do.
Did you jailbreak yours?
No, I never jailbroke it. I just know people who know how to.
Who?
My friend Owen.
Owen who?
I don't remember his last name.
Owen?
Not that one. I Jailbreaking a computer just means that you're taking it off.
You've never heard of that with the iPhone? Jailbreaking your iPhone?
Yeah.
It's like, if you jailbreak your iPhone, you can like download the apps and stuff for free.
Luke
Yeah.
Hudson did that with his 3DS.
Well, of course it's illegal. How does one do that?
I mean, you can
Well,
look up a
step
YouTube
one,
tutorial.
it's illegal, so we don't.
I bet there's a tutorial.
I had Preco.
To download paid software for free, yeah, that's illegal.
Jailbreak DS. He was playing like.
Jailbreaking a Chromebook, not. I don't believe that that's illegal. It's just
It
not.
depends on what you're doing with it once it's jailbroken.
Yeah.
The jailbreaking is not illegal, it's
No.
what you're doing with it once it's jailbroken.
I just want to be able to look at Pinterest without having to ask the administrator to
Isn't
unblock
Pinterest
it.
like not blocked though?
It is. It's usually not blocked because of the tech classes.
Really?
Yeah.
Huh.
Yeah. Because we use it for design projects.
I don't understand,
Like,
why don't y'all figure out how to do Google Chat or whatever so y'all can like text your friends?
We do. Me and
Okay.
my friends do.
Let me see.
for like Gmail, direct message.
Oh, they do have it. Blocked.
Oh.
Okay, we're down to,
Sometimes Pinterest is, sometimes Pinterest isn't. It depends on if we have a project.
I'm so dumb. I'm
okay,
so
we've got
dumb.
about 8 minutes.
Pinterest
So,
is blocked,
I need
right?
to verbally remind you again that I expect number 17 to be finished. You don't have to do more on 16 yet, but 17 needs to be finished. Feel good about it, check the answers to it, learn from your mistakes, all of that kind of stuff. Ready to hand in on Wednesday. This week is a B week again, so I will only see you today and Wednesday, so you won't get that much done this week. But if you want to keep on working on that, you're welcome to. If you borrowed one of my calculators, I obviously need those back. But here's today's puzzle. And if anybody thinks they're good,
Green, blue, yellow.
we'll give them
Green, blue, yellow.
a full class.
Red, green, red, blue, yellow, green.
No. You gotta say it fast.
Fine. I'll do it. Just give me a sec.
All right, is anybody good at this? Want to give it a shot out loud for everybody? Lincoln halfway raised his hand.
Yeah, Leonardo wants to do it.
Yellow, blue.
No, I'm not gonna make him do it.
Yellow, blue, red.
Now, I don't like to embarrass anybody, but if y'all know,
Oh, really?
if y'all know Timmy Manor,
Oh, yeah.
he did it first period today, but he just read all the words. He didn't realize he did it wrong until he was done.
Red, yellow.
Nobody? Nobody wants to give it a shot?
Green, blue, green, blue, yellow, blue, red, green, red, blue, yellow, green, blue, yellow, green.
Oh, actually, somebody
red,
first period today
yellow,
did a
green,
great
green,
job on this,
blue,
but they cheated.
Yellow, green, how's that? Yellow, red, black, white.
Okay, do you know Oliver Hodges?
Yes.
Okay, he did it from the back of the room by taking his glasses off.
There you go.
Because then he couldn't read the words, he could only see the color.
Wait, that's so true.
Good job, Oliver.
That's a pretty good hack. I've never. So maybe if you squint real hard so you can't read the words, your brain might let you do it correctly.
I'll try.
My vision's too good for that.
Give me 1 second.
You just squint enough.
I have literally superhuman vision. It's actually kind of neat.
Yeah, my eyeballs are too good for that kind of thing.